Alright, this is just a short video to show that the RPS has been reconfigured. These two capacitors are now coming out through the controller and charging this parallel bank, in addition to the 150 milliamps going into the two oscillators, which is also charging the parallel bank for that 150 milliamps. DC is going right into there as well. So it's the 150 milliamps DC in from running the oscillators, plus the two capacitor discharges, which are happening at some set frequency currently that has these charging up to about 16 to 18 volts before discharging into the 12 volt stack. And you can see that that's the draw. Right. It's at 150 milliamps. Controller's on. I'll show you the voltages real quick here. Let's see. So it's been running for about 30 minutes now. It's about 320. 12.98, 12.99 volts on the parallel stack. Series stack. Hard to do with one hand. Alright. Series stack is at 24.53 volts. Right. Relative potential here. Minus goes there. And plus goes here. Relative potential that's available to the oscillator is that 11.52 volts. Alright, so it's the 11.52 volts. 11.51 volts at the 150 milliamps, which is driving the oscillator. That's the relative potential that's being used between the negative terminals on these batteries. So that's where it is at 30 minutes. We'll let it finish for an hour, and that's running at half the C20 draw. Normal C20 draw would be 300 milliamps for these batteries. We're drawing half that. So we'll see where these parallel stack end up, and then see if we'll just end up flipping those over to the series stack here next to continue experimenting. Oh, also the DC control voltage that's powering this controller is coming off of the bottom half of the 24 volt series stack, because that's probably the most insulated place from the pulses being delivered over to this parallel stack. So that's how that's configured currently. Anyway, there it is. All charge going into the parallel stack, so it should reach full capacity faster. And powering that light would add another 150 milliamps direct charging from the series stack into the parallel stack and give you light output. And you'd be at the C20 rate at that point over here. You'd have the whole 300 milliamps draw with one light being lit and all the other power being redirected also to charge here. And then once that's charged, switch. So let's see.